Now let's define what is slope and intercept. So we can define slope as b1 is equals to r static sy slash sx, right? So this can be represented by our slope. So here sy and sx are the standard deviations of our two variables. So as we know that we are using two variables here, one is x and one is y, and for the values of x and y we are defining this equation where s and x and sy are the standard deviation. Similarly, we can also define the intercept. So intercept can be given as p naught is equals to y minus b1 into x. So these two equations represents our slope and intercept. Now we can also use some tools or technological softwares in order to calculate different coefficients which will help us to determine the regression. So there are a number of tools which you can use in order to determine these coefficients such as slope and intercept. So here we are basically using StatCrunch, which is a statistical tool, and it can help us to figure out these coefficients. Now let's understand this with an example. So let's consider an example in which we would like to use the explanatory variable x, shoe print length. So here x is representing the length of shoe print, and we want to predict the response variable y, which is height, right? So we have a dependent and independent variable relation here, and we are trying to figure out the height, which is represented by variable y on the basis of explanatory variable, which is x, and x represents the shoe print length. So in this table you can see that the data is given as follows. So in the first row you can see that we have different measurements in centimeters for shoe print, and in the second row we have the corresponding heights in centimeters. So the first thing is that we need to perform a requirement check that whether we can solve this problem with linear regression or not, right? So we can perform three different checks which can tell us that whether this problem is suitable for linear regression. So the number one thing which we need to check is that the data are assumed to be a simple random sample. Number two, we need to create a scatter plot, and that scatter plot shows a roughly straight line pattern. And number three thing which we need to see is that there are no outliers present in the data. So if these requirements are satisfied, then we can make the use of technology to find the coefficients of our regression equation. So if you use this software StatCrunch, or you can use any other software such as R or any other statistical software, and then you will see that you will end up with these coefficients, and your regression equation then can be expressed as y is equals to 125 plus 1.73x, right? So this is our resultant regression equation based on our input data. So if I draw a scatter plot of the data, then you will see that these blue dots here represents our data, and this red line here represents the regression line. And by having a close observation, you can see that this regression line is basically to some extent best fitting our data. So in order to see that whether we can use regression equation for predictions or not, we need to have a look on some points. So we can only use the regression equation for predictions only if the graph of the regression line on the scatter plot confirms that the line fits the points reasonably well, right? So if points are not reasonably fitting well on the scatter plot, then we should not use the regression equation for predictions. Number second thing is that we can use the equation, regression equation, for predictions only if the data used for prediction does not go much beyond the scope of the available sample data, right? So number three thing is that we can use the regression equation for predictions if R indicates that there is a significant linear correlation indicated between the two variables x and y. So the two variables which we are considering here, it is necessary that there is significant linear correlation between the two variables. If there is not enough correlation between these two variables, then we cannot use regression equation for prediction. Also, an important point to be noticed here is that if the regression equation does not appear to be useful for prediction, the best predicted value of a y variable, which is a dependent variable, is its points estimate. And what does it mean? It means that the sample mean of y variable would be the best predicted value for that specific variable. Okay, so here's the strategy for predicting values of y, and on the basis of this we can also see that whether the regression is a good model or not. So in order to see that whether the regression equation is a good model or not, we can use these 3 points which we discussed in the previous slide, and if these 3 points results in a true case, which represents that the regression equation is a good model. So if all these points are satisfied, then we can say that the regression equation is a good model for prediction. And in that case, we can substitute the given value of x into the regression equation, and you see that this is our required regression equation. On the other hand, if the regression equation is not a good model, right? So if it is not satisfying these conditions, then regardless of the value of x, the best predicted value of y is the value of y bar. So y bar is basically representing the mean value of the total y values. Okay, now let's have a quick discussion about the marginal change. So the marginal change in working with two variables is related by a regression equation. So the marginal change in a variable is the amount that the variable changes when the other variable changes by exactly 1 unit. So this is a direct relationship between two variables when one variable is depending on the other variable. So in a marginal case, when you change a little bit in one variable, then that change directly affects the other variable, and if you are changing one variable by 1 unit, then the dependent variable will also exactly change by 1 unit. So the slope, which is represented by v1 in the equation, it represents the marginal change in y when x is changing by 1 unit. So again, let's consider this with an example. So if we have 40 pairs of shoe print lengths and heights, then the regression equation will be given by these coefficients. So in this case, we will have our y hat is equals to 80.9 plus 3.22x, right? So here the slope is 3.22, this one, and it tells us that if we increase shoe by a length of 1 centimeter, then the height which is being predicted by this coefficient will also increase by a factor of 3.22 centimeter, right? So this coefficient is basically telling us that how much marginal change will occur in the predicted variable if we change the slope. So there are a number of visualization techniques which we can use in order to observe our data and our regression equation, but the most standard plots which we use in such problems is the scatter plot. So let's have a look that how can we make an observation from scatter plots.